The Milky Way seems a tranquil place. Hundreds of billions of stars, serenely spinning through the cosmos. But journey inwards, through the gas and dust that shrouds the galactic core. And you see a curious sight. Stars orbiting seemingly empty space. Something dark and ancient lives here. A hole in the fabric of the universe. Every one of those points of light in the night sky is a strange and fascinating place. Magnificent suns with countless planets orbiting around them, alien worlds beyond imagination. But the strangest and most fascinating places out there by far are dark and unseen. An invisible monster is lurking in the center of the Milky Way. A monster that drains the colour from the universe. With the power to destroy worlds. And stop time. We've named the monster Sagittarius A star, and we believe it to be a black hole. Sagittarius A star has played a major role in the evolution of our galaxy, and may even have influenced the formation of stars and planets like ours. But there is so much more, because black holes like Sagittarius A star present the most profound intellectual challenge. They are part of nature, just like you and me, so we should be able to understand them. But they are holes in the fabric of the universe. They are gravitational prisms from which even light itself can't escape. And in trying to understand them, physicists have been led to completely reassess our most basic understanding of reality. But there are answers hiding in the void for those brave enough to seek them.
It is said that fact is sometimes stranger than fiction. But nowhere is that more true than in the case of black holes. Black holes are stranger than anything dreamed of by science fiction writers, but they are firmly matters of science fact.
And we copy at go for deploy. You look out and this thing is so big, you certainly know that it's really over the head of the shuttle.
In the summer of 1999, NASA's flagship mission for X-ray astronomy was released from the shuttle cargo bay.
There is nothing as beautiful as Chandra sailing off on its way to work.
High above the Earth, Chandra scanned the sky, hunting for some of the hottest regions in the universe. Exploding stars and clusters of galaxies. But on September the 14th, 2013, after 14 years, Chandra chanced on something else entirely. telescope gazed into the constellation of Sagittarius, hoping to observe a large cloud of hot gas. Instead, it recorded a flash of X-rays, just a few pixels across, coming from the apparently empty space in the galactic core. Something had got very hot for a very short period of time. It's thought that the flash seen by Chandra may have been an asteroid, tens of kilometres across, ripped apart and burning up in a fireball 300 times brighter than the Sun. The culprit? Sagittarius A star. The asteroid's destruction was our galaxy's black hole, signalling its presence to the world. 20 years ago, we didn't know for sure that there is a black hole at the centre of our galaxy, but by measuring bursts of radiation and observing in detail the orbits of stars close to the galactic centre, we now know that Sagittarius A star definitely exists, and we've been able to measure its mass. It is around 4 million times the mass of our Sun, which makes it a supermassive black hole, one of the strangest and most powerful objects in the universe. And we've begun to suspect that Sagittarius A star isn't just some strange thing that sits tens of thousands of light years from Earth at the centre of the galaxy. It has played a crucial role in the evolution of the Milky Way, and the whole story began with the death of one massive star. Soon after the dawn of time, the cosmos was home to colossal stars. Hundreds of times more massive than the Sun. Stars that burnt blue with intense heat. But the brightest stars are the shortest lived. One lived a particularly fast and furious life, burning through its nuclear fuel in just a few million years. And with nothing left in the tank, gravity took over. The star collapsed, ever smaller, ever denser, until it seemingly disappeared. The remnants of the star, now smaller than an atom, lost from the universe. All that's left is a ghost, a black hole. The genesis of Sagittarius A star wasn't some bizarre one-off event. It's possible that almost all early stars became black holes when they died. Black holes are simply what happens when gravity goes unchecked, compacting matter so densely it tears a hole in the universe. In the vicinity of a black hole, space and time behave in very counterintuitive ways. In fact, this river provides a beautiful and surprisingly accurate analogy. If you're close to a black hole, you can think of space itself as flowing towards the black hole. Now here, the flow is not too fast. And so you can imagine I could jump into that river, I can swim faster than the river of space, and so I can escape out into the galaxy. But as you get closer to the black hole, the river of space flows faster and faster and faster. A collapsed star is so small and yet so massive that close to it, the gravitational forces become overwhelming. There is no limit to the speed at which the river of space can flow. There's a place where the river becomes a waterfall, where no matter how fast I swim, I could never escape upstream. And that's what happens in the vicinity of a black hole. The river of space flows at and then faster than the speed of light. Light itself can't move fast enough to escape. And that's what Sagittarius A star is. It's a waterfall in the fabric of the universe. From the moment the black hole formed, the seed of Sagittarius A star had a heart of pure darkness. The interior forever hidden from view, shielded from the rest of the universe by a boundary in space. The event horizon, the ultimate point of no return. As we approach the event horizon, we get our first glimpse of the true weirdness of black holes. Einstein taught us that space and time are not what they seem. They are merged together into a kind of a fabric, the fabric of the universe. It's called space-time. And Einstein also taught us that the presence of massive objects, stars and planets and galaxies, curve and distort the fabric of the universe. And that's what we feel as the force of gravity. But that distortion is not only in space, it's also in time. As you go closer and closer to a massive object, the rate that time passes slows down. So if I look towards a black hole, I see time passing slower and slower and slower until, on the event horizon, time stops. Sagittarius A star was born a waterfall in the fabric of the universe, where space flows faster than light and time grinds to a halt. But our black hole was still just a baby, dwarfed by the stars around it. It was nothing like the monster it would become. Sagittarius A star today is 4 million times the mass of the Sun. There has never been a star that massive. So it must have formed by the collapse of something much smaller. And then it must have grown over the lifetime of the Milky Way by eating stuff. Unfortunately, there has been a lot of stuff around for it to eat. The young black hole's inexorable gravitational pull meant there was no escape for anything that strayed too close. Sagittarius A star began to grow, pulling on nearby stars, before ripping them to shreds and feasting on their hot plasma. The black hole gaining more mass and more gravitational power. But we don't think there were enough stars nearby for the black hole to grow supermassive on a diet of stars alone. Instead, it developed a taste for more massive prey. When another black hole passed close to Sagittarius A star, they became locked in a gravitational embrace, spiraling towards each other, approaching half the speed of light before colliding. Sagittarius A star cannibalized its cousin, creating ripples in the fabric of the universe itself. More meals were to follow. Black holes, stars, gas clouds, whatever ventured too deep into its lair. And as our black hole's power and influence grew, its surroundings were changing too. Around the galactic core, hundreds of billions of stars were in orbit, slowly spinning around their common centre of mass, evolving into the familiar spiralling disk, the majestic Milky Way, with Sagittarius A star at its core. Sagittarius A star became what we now call a supermassive black hole, many tens or even hundreds of thousands of times more massive than any star in the universe. And Sagittarius A star is not unique. We now think that virtually every large galaxy has a supermassive black hole at its heart. Chandra has looked beyond the Milky Way and observed countless supermassive black holes lurking at the hearts of the myriad galaxies that litter the cosmos. To sculpt the galaxies around them, the centre of our young galaxy was rich in gas and dust. More offerings to feast on. This was a gluttonous period that marked a new era for the Milky Way's supermassive black hole, when the invisible monster became sculptor of the galaxy. Creation and destruction often go hand in hand in the universe, and black holes are no exception. Sagittarius A star is certainly not only an agent of destruction, because the material that falls inwards towards the black hole doesn't all vanish across the event horizon. A lot of it goes into orbit around the black hole. And that region is tremendously violent. There are magnetic fields that swirl around and become twisted and distorted, and they can throw material out along the magnetic poles of the black hole, making jets that sweep through the galaxy. It's only recently that we've grasped the true scale of Sagittarius A star's eruptions. Just over a decade ago, a completely unexpected discovery was made, likened to finding a brand new continent here on Earth. The Fermi Space Telescope was built to detect gamma rays, the most energetic radiation in the universe. As Fermi orbited the Earth, it constructed a map of the sky and saw, emerging from the plane of the Milky Way, two colossal bubbles of material, each 25,000 light years across. These bubbles are superheated gas. If our eyes were sensitive to the wavelengths of light emitted by those bubbles, they would span half the sky as seen from here on Earth. And they point back to the centre of the galaxy. It looks like their origin is Sagittarius A star. If you think about that, Sagittarius A star is big, but not big on a galactic scale. It would fit comfortably inside the orbit of Mercury in our solar system. Though our black hole is only a fraction of the size of the galaxy around it, it had become sculptor of the Milky Way. Every few million years, the dense ring of material circling our black hole, was accelerated by twisting magnetic fields into fiery jets of superheated matter. Jets so powerful, they stripped the atmospheres from any planets in their path, and radiation rendered every Earth-like world within 1,000 light-years uninhabitable. But such was the scale of Sagittarius A star's outbursts that far, far out in the galaxy, destruction turned to creation.
If you're looking for reasons why life not only began here on Earth, but was able to prosper for the almost 4 billion years it took for it to evolve into the complex living world that we see today, then it might seem a bit of a stretch to point to a supermassive black hole at the centre of our galaxy and say that's one of the reasons why. We're now beginning to suspect that those great outpourings of energy of Sagittarius A star played a crucial role in making this region of the galaxy one in which life can flourish.
Because the hot gas ejected by Sagittarius A star had a calming effect on the galaxy.
Now you might think that a hot gas cloud would produce more stars, but in fact the opposite is true, because hot means that everything's moving around very fast, and that makes it more difficult for gravity to grab hold of everything and collapse it to form stars. So Sagittarius A star reduced the number of stars that formed in this region of the galaxy. And that's a good thing. Imagine if there was some giant star that had formed close by that exploded in a supernova explosion. Well, that would not be a good thing if you're an amoeba and you have designs one day on evolving into Einstein. So Sagittarius A star turned what is potentially a violent region of our galaxy into a peaceful one.
The warm gases pushed out by Sagittarius A star slowed the rate of star formation. And around one small yellow star, in a quiet region at the unfashionable end of the outer spiral arms of the galaxy, 4 billion years of stability made all the difference. Now, of course, there are many things that are necessary for life to exist on a planet. The list is unimaginably vast. But I think it is interesting that on that list, there is the presence of this strange object, a black hole, Sagittarius A star, tens of thousands of light years away, the centre of our galaxy. Having cleared out much of the gas, dust and stars that once lay close by, there was little left to feast on. Our black hole fell silent. The enormous bubbles spotted by Fermi, echoes of a glorious past. Today, Sagittarius A star is a sleeping giant, a brooding beast operating on a slow simmer. Sagittarius A star's journey from violent destroyer to sculptor of the galaxy to the sleeping giant that we see today has been pieced together over the last 20 years by observational data from telescopes such as Chandra and Fermi. There's a very big difference indeed between knowing how a black hole interacts with its environment, how it sculpts a galaxy, and what it actually is at a deep level. What is it really like inside?
Black holes challenge the most basic principle about the predictability of the universe and the certainty of history. Nothing could get out of a black hole, or so it was thought.
It's by looking into the future that we're beginning to explore the deep mystery of black holes. Dozens of stars orbit around Sagittarius A star. some passing just a few billion miles from the event horizon, a hair's breadth on galactic scales. These flybys could have fatal consequences. Some of these stars will likely have planets in orbit, planets that may stray too close to the beast. A moth to a flame, pulled from its parent star towards the abyss. If the planet survives its journey inwards, and we could stand on its surface and look out into the universe beyond, we would see space and time becoming increasingly distorted. But eventually, tidal gravitational forces become too strong. Inexorably, the singularity awaits. The end of time, where all paths terminate. Over trillions of years, all the stars around Sagittarius A star will gradually fade and die. On more and more alien worlds, the dawn will fail to come. But our supermassive monster will go on. Its secrets are sealed away inside, seemingly forever. We predict that one day, black holes will be all that remains in the universe. The final dark age. If nothing can ever escape from black holes, if Sagittarius A star really is an eternal prison, then this is the end of the story of the universe. Darkness littered with holes in space-time. But we don't think this is the end of the story. We now believe that even black holes die. And their deaths come at the hands of what might seem an inconsequential detail discovered almost 5 decades ago. In 1975, Stephen Hawking published a remarkable paper in which he showed that black holes are not completely black. They glow faintly, they have a temperature. And here's his beautiful equation for the temperature of a black hole. And you can see that there's something deep going on, because this has got all the physics in it. With this thing here, h bar is Planck's constant, that's to do with quantum mechanics, a subatomic world. C is the speed of light. G is the strength of gravity. This kb here is Boltzmann's constant, that's to do with temperature and thermodynamics. And this m here is the mass of the black hole. It's even got circles, but it's got a pi in it. Hawking's conclusion proved to be irrefutable, and the implications are huge. If something has a temperature, then it radiates. That's why if you put your hand near something that's hot, you can feel it. And so over timescales that are billions and billions and billions and billions of times longer than the current age of the universe, Sagittarius A star will eventually evaporate away. Very gradually, the Hawking radiation will erode Sagittarius A star, smaller and smaller, until many trillions and trillions of years into the future. In a final burst of light, our black hole will die. And then there will be darkness for all eternity. Now you may say quite legitimately, well, why do we care? Why does it matter if black holes evaporate away sometime in the far, far future of the universe? There'll be nobody around to see it.
But the discovery that black holes evaporate raises what I think is the most profound question in the history of physics, certainly over the last 100 years, and that's no exaggeration. See, what happens if I set fire to this piece of paper with Stephen Hawking's equation written on it? I cause it to evaporate away. Do I destroy everything? Do I remove every piece of information, including the equation, from the universe when it burns away? Well, the answer is no. If I could collect every ash, every molecule of gas burns off into the atmosphere, then in principle, I could reconstruct the piece of paper and everything it contains, every piece of information on this piece of paper, including Stephen Hawking's equation. But can that be true for black holes, the ultimate gravitational prisons, these objects in the sky from which even light itself can't escape? When they evaporate away, do they return the information about everything that ever fell in back to the universe?
Black holes ain't as black as they are painted. They are not the eternal prisons they were once thought. Things can get out of a black hole, both at the outside and possibly to another universe. So, if you feel you are in a black hole, don't get out. There's a way out.
If information somehow escapes from Sagittarius A star as it evaporates away, the implication is profound. Black holes aren't tombs. They're gateways. We now believe that anything that falls into Sagittarius A star will live on. Not as a physical object, but as information. Escaping from the heart of darkness, encoded in the Hawking radiation in the far future.
The memory of all those worlds that fell into Sagittarius A star over the entire history of the Milky Way galaxy is somehow written in the ashes of the universe in the far future. But the real treasure lies in the explanation of how the information gets out from those eternal prisons. Now, what I'm going to tell you is going to sound absolutely bizarre. It's going to sound like science fiction. But here goes. When the black hole has evaporated away, about half of it has gone, the interior becomes in some sense the same place as the distant Hawking radiation that was emitted eons ago that's out there in the far reaches of the universe. It seems that space-time wormholes open up between the interior of the black hole and those distant parts of the universe, and it's that allows us to read the information inside. Now that is supposed to sound weird, and I should say that nobody really agrees on the physical picture of what's happening. But what everybody agrees on is this: the black holes are telling us that our intuitive picture of reality, of space and time, is wrong. The idea that this place is close to this place and that time ticks along is wrong. There is a deeper picture of reality in which space and time do not exist.
Our attempt to answer a seemingly simple question about the fate of objects that fall into black holes has led us to a profound and quite unsettling conclusion. Space and time, concepts so foundational to how we experience the world, are not fundamental properties of nature. They emerge from a deeper reality in which neither exist. We're still a long way from fully comprehending the secrets of black holes. But we are beginning to lift the veil. Far from being a mere cosmic aberration, Sagittarius A star is a part of our history and of our future. Our black hole not only made us who we are today, it's our teacher, slowly revealing the deepest mysteries of the universe. Secrets sealed away for so long, inside a place beyond forever. The moral of the story is this: understanding the book of nature is hard. And so the more of nature we observe, the more chance we have of finishing the book. Now, the strangest objects in nature by far are black holes. And so I suppose it's not surprising that by peering over the horizon and into the darkness, we have caught a glimpse of something deeply hidden, the underlying structure of reality itself. So if we want to understand the meaning of it all, we can't restrict ourselves to the intellectually safe confines of our planet. We have to look out there, to the universe beyond.